Hi guys, welcome to the tutorial on perpendicular lines in coordinate geometry. What we're looking at today is what perpendicular lines are and looking at the relationship between their gradients. So first of all, we're going to revise what is meant by perpendicular. So what are perpendicular lines? Well, hopefully you remember that perpendicular lines are lines that meet at a right angle or 90 degrees. Perpendicular lines are also represented by that little symbol there. It looks like a upside down T or even a right angled lib extended. So basically it means we're looking at two lines that meet at 90 degrees. So in order to do this, we're going to start off with our axes, X and Y, as we usually do. I'm going to have a look at two particular lines. First of all, I'll look at a blue line called y equals x, and then we're going to look at another line. This time it's going to go the opposite way. I wonder what equation that could be called. Well, it can't be y equals x, because that means that the gradients will be the same and be the same line. So what is meant by a negative line? Hopefully you would have said a negative gradient. So what I'm going to do now that I've got the two lines there, I'm going to put a little purple right angle in there. So we can see that they both meet at 90 degrees. So what I'm going to ask you is the question is, what is the gradient of the blue line? Hopefully you said the gradient is equal to 1, because that is y equals 1x. Likewise, I'm going to ask you the question, what is the gradient of the green line? Hopefully you said negative 1, because it's negative 1x. Remember, the formula of a straight line is y equals mx plus b. In this case, the m is negative 1 for the green line, and for the blue line it's 1. Now, unlike the last time when we looked at parallel lines, well, the gradients were equal because they were exactly the same steepness. Here, obviously, they're different. So what is the relationship between this? Well, the rule that we'll be learning says that if I times the two gradients together, the answer will always be negative 1 if the lines are perpendicular. There's a little sign again. So if the lines are perpendicular, then if I times their two gradients together, the answer will always be negative 1. In this case, you can see 1 times negative 1 equals negative 1. So that works out. So let's have a look at a couple of questions that they could ask us about this. So let's say this is EG1. First of all, are the lines y equals 3x plus 1 and y equals negative 1/3 x plus 4 perpendicular? Okay, so are these two lines perpendicular? Well, we know they're not parallel because obviously the gradients are not the same. But we know if they're perpendicular, then if I times the two gradients together, then the answer will equal negative 1. So let's have a quick look at this. Well, the first gradient is 3. The second gradient is negative 1/3. Now if we do that in our calculator, okay, you should come up with the answer of negative 1. However, you should be able to do that without a calculator, because 3 times negative 1 is negative 3, and 3 over 3 makes negative 1. What do you notice about these two things here? Well, hopefully you'll realise that if I put that over 1, they look like the same thing, but they're flipped over. We can call this because one's positive, one's negative, the negative reciprocal, which is very important, because if I know that 3 is one of the gradients, then we know that the other gradient, if they are perpendicular, must be the negative reciprocal of that. And that's going to follow on to the next style of question. E.g. 2. We spoke about that if we multiply the two gradients together, they need to equal -1. But also we know that the other gradient is what we call the negative reciprocal. It's a quick way of doing things. So in that case, we know if the first gradient is 3/4, then the second gradient must be the negative reciprocal. So that means the negative reciprocal means flip. Therefore, the gradient is going to be the -4/3. It's a little bit tough, guys. It's more challenging than the parallel lines. I suggest you simply revise that, give it a go, and see how you handle it. Hope you enjoyed it, and if you got any questions, make sure you ask. Thanks, guys.